Alright, so welcome to the session, and I hope all of you guys are doing good. So let's get started with today's session. So today we are going to talk about recurrent neural networks. And if you guys have attended the previous sessions where we have discussed about the artificial neural network and convolutional neural network. So what we have discussed is that in the artificial neural network, it is good for us when we are using the tabular data. Right? Where I have the structured data with me, where I have various features like suppose I want to predict the car price, house price, whether my customer will purchase the product or not. So those type of problem statements. And when my data is very much in the tabular format, we can use the artificial neural networks. Second, we discussed about whenever we are encountering the images. So in that case, we are focusing on convolutional neural networks. So whenever we have to do some predictions on image type of data. So in that case, CNN is what we are using. And at the same time, uh, we have to do a lot of processing before we do the predictions on that. We took one of the examples as well. Now, today we are going to focus on the recurrent neural network. Again, these sessions are mostly designed for those guys who are very much layman, having zero idea about what it is, right? So I'm not going to talk about very complex mathematics and all. The only thing is that what it does and how it does. So I'll give you the brief understanding of the same, right? So if you are already aware of that, then maybe this is not the session for you. It's just only for the laymen, right? So the RNN is recurrent neural network. And as we have ANN, as we have CNN, then what is the need of RNN? What type of data do I have to process? Why they have come up with this concept? So basically, when we are having the sequential data, so in that case, RNN is the option. RNN is the only option I can say out of these three networks. RNN is the only option which we have to process the sequential type of data. For example, let's say text data. Suppose I want to predict whether the feedback which was given by the end user is positive or negative, right? So it's a textual data. It's a sequential data. There are certain challenges where I cannot use ANN. That's why RNN coming into picture. That is what we discuss as well. Second is time series data. For example, let's say I want to predict the stock price, right? So it's a time series type of data. So there also we can use RNN. Third is the speech data. That means when I'm speaking something and machine is understanding it and giving me some responses. So in that case, this type of neural network is coming into picture. That is RNN, recurrent neural network. Now, why they have come up with this? What is the need of it? Now, let's assume that I am getting a lot of feedbacks from my customers based on, let's say I'm running a restaurant, right? And I am getting the input, the feedback and the output, which I am tagging for now, whether it's positive or negative. I love pizza. It's a positive feedback. So 1. The ambience is not good. The feedback is negative. So 0 coming in. Music is too loud. It's again negative. So 0 coming in. And burger was amazing. That is positive. One thing you will notice here is that whenever, like, if you remember in the ANN, what we have discussed is that I have certain set of inputs. And then we are passing the neuron. And then we are doing the prediction. That is my network. Here my inputs are fixed. My inputs are fixed. Suppose I want to predict my car price based on the age of my car, based on the mileage of my car, based on accidental and not accidental, and based on the automatic and manual. So I have four fixed inputs. But if you see in the sentence type of data, my inputs are not same. My inputs are varying, right? If I will try to put this guy in the artificial neural network, I cannot do that because it can only take one set of inputs, one number of inputs, right? I can say n number of inputs, where n is 4 in this example. But here you can see how many inputs are there. If you see this sentence, I have three inputs. I love pizza. If I see this sentence, I have 1, 2, 3, 4, 5 inputs. Here I have 1, 2, 3, 4 inputs. Here I have 1, 2, 3 inputs. So basically my inputs are varying. And because of that, normal network like ANN will not work in this particular scenario. Now, what is the solution they have come up with? So they have told, okay, let's do one thing. Let me try to do some algorithm. Let me create some network, which will be like quite repetitive type of network, right? It will be something like a repetitive type of network. So what they have done, they have come up with this new type of network, which looks like this. You will see in many textbooks as well. Something will be like this, you can see. Right, this type of network you must have seen somewhere in the book or maybe some other diagram as well. But this is one of the diagrams which you can see in quite some of the textbooks. Now, what it means, how it works, why it's very much looking complicated. Let's try to understand this. As the name is recurrent neural network, there is some recursion is happening, right? There is some recursion is happening. What is that recursion? Let's try to understand. Let me open this network and let me flat it out, right? Let me flat it out. So how it will look like? So this way I can open up any number of what do you say network, right? Here you can see that I told you it's a repetitive. So here you can see that it is open. I'm opening it, right? I'm opening this network. Now this is my input, my first input, my second input, my third input, and my fourth input. For example, if I go back to this sentence, music is too loud. So what will happen here? Music will be the first input. It will go inside the neuron. Here you will find the neurons. Some weight will be assigned from the back, right? Because if you want the continuation, so this should go back, right? So there should be some input from the source also, from the back also. So normally we put the weight as 0 in this from the back, right? From here I will get certain weights, certain importance from this particular word. Machine will initialize that initially, and then it will fine tune further. The way the other network works, the same concept. Now here, this input gets multiplied and some output will be coming in, which is the input for the next word. Music is too loud, right? So here you can see I have inputs coming in. So again, I am passing certain weight for this, doing certain multiplication, and then I'm getting some output. Again here, weight 3, doing some multiplication, output 3. Again, some multiplication x4 and output 4. Or I can export this as output 4 as well. So this, if I will have further network, I can move this to the next network, like something like this, a next coming in, next word coming in, or it will directly go as an output, right? So basically the idea is what? Suppose let's say my sentence is now burger is amazing. So in this case, I will not have this 4 networks, right? I will only have 3 networks. Burger was amazing. That's it. Then I will get the output. Next, my sentence I have, let's say the next sentence is the ambience is not good. So the ambience is not one more network coming in good. So as every sentence is having different number of words, based on that, recurrent neural network automatically finds that out, that okay, how many words are there, and based on the number of words, it will help me to find out the, it will help me to calculate by opening up that network, right? So this network will open up based on how many inputs we have. Inputs in our example is number of words which we are using, right? So that is the idea. So now, as I discussed, the problem is that when I'm, again, let's try to understand some of the idea, right? For example, let's say you are watching a Netflix series and Netflix wants to predict the next show which you will watch based on your previous watch history. So in the traditional neural network, that is ANN, it takes the input individually and does not consider the past inputs. Basically, there is no memory in this. There is no memory, right? Whatever you are passing the input, based on that, the output will be coming in. It will not store your past history of what type of shows you have seen in the Netflix. So it has no memory and it treats every input independently. Which one? The normal neural network, the artificial neural network, right? Now, why does this fail? The order of, again, if I talk about this, right? If I talk about the features here, if I talk about the what do you say? One more scenario. Try to understand this. Suppose, let's say I am trying to put this sentence somehow I manage to solve the problem statement using ANN. But what is the problem here? Here the sequence of the word is very important, right? In the normal ANN, what happens? I will be one input, love will be one input, pizza will be one input. But suppose if I shuffle the sequence, as of now, it's just three lines, three words. If I'm having more words, and if I shuffle the words, automatically the meaning of the sentence will change, right? So that's the second reason why I cannot use the normal artificial neural network, because the first reason is my inputs are varying. I can have any number of texts. I'm not sure how many texts will be coming in. And second is obviously the sequence of the text is also important. Right? So whenever I'm writing the email, so I have to pass the proper details, right? Hi, how are? So automatically you comes in. You must have seen this type of scenario. Let me show you this. Suppose you're writing the email here. Hi, how are? So automatically this you is coming in, right? So how this you is coming in? The you is coming in because of your recurrent neural network, right? So basically this type of solution is what we are using, trying to predict the next, word, right? So again, it's quite famous, right? Recurrent is the key of all the latest networks which we are discussing, like which we are using. For example, transformers, encoder, decoder, which we are going to discuss in the next session. So those are just the key of like the root is RNN, right? The root is RNN. So why does it will fail? Because obviously order matters, right? I cannot pass love first, then I first, then pizza. I cannot do that, right? So the order of the word matters a lot. For example, simple. I love machine learning. I love machine learning. I cannot write machine learning loves me, right? That is obviously wrong. So I have to pass the proper sequence of the word. In that case, it will work fine. And second problem is obviously in the normal neural networks, I cannot remember the past. I can only remember the future. I can only predict the future. I cannot remember the past. In the recurrent neural network, what I want is I want to remember the past as well. Suppose I am writing a big sentence. I am, for example, I am from Gujarat and I did my school from Ahmedabad and I did my engineering from NIT Surat and I don't know I want to predict something. I don't know Gujarati, right? Now, see, to understand this context of the word Gujarati, I have to go to Gujarat, right? So if I am not aware of the history, if I am not aware of the past details, I cannot predict this word, right? So this type of sentences where I want to predict something which is dependent on very way far from the this word, right? It's very far. So in that case, your normal ANN, because ANN does not store your history or past. So because of that, I cannot do that, right? That is the idea. That is the reason RNN they have developed, right? That is the reason. So RNN can remember in previous inputs while processing the new ones. It works well for time series data, as I mentioned, speech recognition, text generation, stock market predictions, and so on. Right, so we can create a lot of interesting algorithms as well using the RNN and advanced concepts to do the prediction in the stock markets as well. Now there are different types of RNNs are there. One is known as your many to many RNN. Many to many RNN. That means what? I have multiple inputs. I have multiple inputs and I have multiple outputs as well. Right? This is my many to many RNN, where my input is also a sequence and my output is also a sequence. For example, language translation. I want to convert one sentence from Hindi to English. So what I will get? Once I pass the English sentence, or if I pass the Hindi sentence, I will get the English sentence, right? So basically, I am passing Hindi sentence, I am getting the English sentence. So one word has one output, another word has another output, and so on and so forth. So this type of RNN is known as many to many RNN, right? For every input, there can be an output. Second is your one to many RNN. For example, I have an input, one to many RNN, right? So in this case, what happens? My input is only one. My input is only one, but my output can be many. My output can be many. One input and multiple outputs. Use cases, image captioning. Suppose I am passing the image and I want to do the captioning of the image. So in that case, I can use this one to many RNN where I am passing the image as an one input and captioning will happen for every object, let's say. So in that case, that is image captioning option for one to many. Next is your many to one. It's a simple example, many to one. I am passing the feedback. I am passing the feedback. And based on that feedback, I am getting one output, whether it's positive or negative, right? I love this restaurant. So this is my input and my output is coming out to be positive or negative. So that is my many to one type of scenario, right? So these are the different types of RNNs which we have. It's purely based on what type of requirement you are looking for. Based on that, you can go ahead and you can use that type of RNN. Now, how RNN works? Let's try to understand. Let's take with one simple example. Let's say we are predicting the next word. I am learning. And I want to predict something. So what happens is I goes in the memory. I goes in the memory. It updates the memory. Again, M goes in the memory. Again, learning goes in the memory. Right. So that is my input data. Something like this. I am learning. I am learning. So that is my input data. This is my inputs. Right. Second is your hidden state. here you can see we have neurons coming in. These are my hidden state, right? Where I can do all the calculations. One more thing is that if in the first layer I have 3 neurons, same will be present here also. Same will be present here also. Why? Because it's recurrent. Whatever neuron you are designing, how many neurons you are planning to put inside this, as it is recurrent, right? So it is repetitive. So if it is 5, then the next will also have 5. If all the 5s are ReLU function, then all will be ReLU function only, right? So there will not be any change. So here, all my number of networks will be same. So in this hidden state, what happens? At every step, the hidden state stores past information and updates itself. At every hidden state, or I can say at every hidden state, at this point, try to understand. It stores the past information, right? My past information is coming to the hidden state and it updates itself. So as I coming in, it will get to know that, okay, the previous word was I. Based on that, this will update. And then I will get the output. That is the output prediction, processing all the words in the network and predict the next word. I am learning, let's say machine learning. So it will predict. Again, there will be context also. As of now, I can learn anything, right? But there will be certain context that I am a machine learning professional and all those things. Then I can say, yes, I am learning machine learning. So that type of predictions we can do, right? I'm not getting into the maths, but there are certain complex mathematics involved behind that, right? So basically there is a concept of hidden layer is equal to 10h weight of h, ht minus 1 plus wx x1 or xt I can say, and yt is equal to wy ht. So all this is like complex mathematics, which I am not discussing as of now. As a layman, we are understanding that, okay, I can have multiple inputs and based on that, the output will be coming in. The only reason for coming up with the RNN is that my ANN cannot solve those problems. I already discussed that multiple times. Now, what are the problems with this RNN? Obviously, there are limitations with RNN as well. That's why the new things came in. So the problem with RNN was very, very interesting problem, which is known as vanishing gradient problem, right? Vanishing gradient problem. Now try to understand this. If you remember, we discussed about the backpropagation concept where I'm updating the weights, right? In the artificial neural network, we discussed briefly that we are updating the weights. So here also the same thing will happen. For example, let's say I am having this neural network. And I have the output here. These are my inputs. And obviously neurons will be there. Right. So now I am passing certain sentence and it is trying to predict something. For example, let's say I am enjoying this food here, something like this. And my machine is trying to predict the whether it's a positive feedback or a negative feedback. Let's say my machine is predicting it as a negative feedback. However, it is positive, right? Machine is predicting it as negative feedback. So I have to fine tune this, right? I have to fine tune this. I want to reduce this error. So I will go back. I will change all the weights, right? There will be certain weight here. There will be certain weight here. There will be certain weights here, weights here, weights here. So I have to basically optimize these weights. So from here to here till the time I will come here, right? Optimizing the weight is basically nothing but it's all the game of derivatives. A lot of derivative multiplication happens. Dy by dx into dwn by w n minus 1. So basically a lot of multiplication will happen, right? Now when we are updating the weights, these numbers are very smaller numbers. Let's say here I'm having 0.1, here I'm having 0.1, here I'm having 0.1, here I'm having 0.1. I want to update this weight. So basically, a lot of multiplication will happen, 0.1 into 0.1 into and so on. So this will become very small. This change in the weight will become very small. So basically, vanishing gradient. Gradient is nothing but your derivatives. While you are trying to optimize your recurrent neural network, when you are trying to update the first word, when you are trying to update the weight of the first word, by the time I reach to the first word, my gradients become very small. That means almost there is no updation happen. Because if I try to update some weight here, I'm multiplying that weight with this very small number. How much the weight will change? Negligible, right? So because of that, this entire vanishing problem comes in. And that is one of the challenges which we have with the recurrent neural networks. And why it is happening like this? Because see, I somehow want this importance of these words and I want to carry it forward. I want to somehow carry forward this importance of word. For example, let's say I gave the example of that Gujarat wala example, right? I gave this example of Gujarat thing. So now by the time I will update this weight of this input feature, it is going to be very small. I cannot understand what is this word. I will not able to identify what is this word because this weight is not changing much. It is the importance of this weight is not changing much. So somehow if I get this information of Gujarat till here, then I can solve that vanishing problem. I can somehow take care of that vanishing problem. That means I want to remember in my memory that, okay, Gujarat is present here. Somehow I will take this and take the context of Gujarat all over the place. Somehow I can take this up till here so that I can manage to update the weight of Gujarat as well. So that is the problem with the RNN, which is not happening in this scenario. The word which is very, very far and it is very important for me, still it is not able to give me that relevance. The reason is that the vanishing gradient problem. Now, what is the solution here? The solution is that they have come up with two architectures. One is known as LSTM, right? And second is known as GRUs. LSTM is basically nothing but long, short term memory. And GRUs are known as gated recurrent units. These are the two architectures which they have come up with, which is basically taking care of the vanishing gradient problem. It is trying to fix that problem. That once I will go ahead and try to understand the context of the older word, I can very well do that without any problem, right? Again, the architecture of these LSTMs are also very complex. I'll show you the architecture here. I'll not explain that in detail, but I'll give you the idea. Give me a second. So here you can see that bit of a complicated architecture, which you can see here. This is the architecture of LSTM. Lot of operations are happening here. Lot of operations are happening here, and it is trying to solve that problem, right? It is trying to solve that problem. Let me show you this. Yeah. So here you can see that my input is coming in from back. Some input is coming in, and some operations are happening, right? In between, some operations are happening, and my output is going in. You can see there is one more flow is happening. And this flow is actually trying to save the long-term dependency. That means suppose I am at this point standing here. Suppose at this point I am standing in the Surat, let's say. I want to somehow take this Gujarat context as well. So basically what happens here, it is going to flow all the context of the past words. This architecture of LSTM is trying to take the flow of all the past words in the input as well, right? While we are predicting something, it will consider the past values also. So that is why it is known as long short-term memory. It is trying to capture the long-term memory, right? and also trying to capture the short-term memory as well. Short-term memory means what? The latest words, the nearby words, and long-term memory is what? The older words, right? So it will consider both the scenarios and then trying to predict. It's something like, let's say I'm reading a lot of stories, right? I'm reading one big story, but in that big story, there is one character came in at the very start, and that character will come in the middle of the movie as well. If I'm not aware of that, who was that character, I will not able to understand now what is this, who is this character. So I have to be somehow storing the information about that character, right? If I'm not storing that, then I will not able to understand what he is doing, who is this guy, and so on. So the same thing is, this is how the human brain processes, right? If I'm reading any story, I should be aware of, I am capturing the important things in my mind, and I will use that for the future understanding. And same thing is machine is also doing here in the RNN, that what are the previous important words for me. I will take that into consideration, and I will also consider the latest words. Based on that, I will decide. Gujarat is coming from the back, and here I don't know the language. Gujarati automatically it will understand, because Gujarat is coming in, language is coming in, so obviously it can be Gujarati, right? So that is how it works. And again, it's a very, very interesting innovation came in. And after that, on top of this, they have come up with very another different advanced algorithm as well, which is now you're using in your day-to-day task like GPTs and all, where they are using transformers and making it more powerful. But the entire breakthrough happened because of RNN, right? When RNN came in, after that, more ideas came in. You will see, once you will start reading some of the scientific documents, you can see that after RNN, lot of other algorithms came in on those lines, and then slowly they went into encoder, decoders, and your transformers. But it's an amazing concept which they have came up with, and because of that, we are seeing a lot of interesting stuffs these days, right? So that is about the idea. Let me go through some more thing. Give me a second. Yeah. So what I'll show you one code which I have created where I'm trying to predict the time series. I want to predict the stock prices, right? I want to predict the stock prices. So I have the code ready with me. I'll just run it and I'll explain what's going on here. Just give me a second. So at this folder, the data is there. So I'm just passing this location. And here you can see that I am passing on the file at which I have the stock prices. Let me show you the data here, how the data will look like. So here you can see that we have the data for open price, high, low, close, and volume, right? So based on that data, I will go ahead and I'll train my model. Open price of the stock, high price, low price, and close price. And here you can see that my model is running. Let me, in the meantime, explain what's happening here. So here I'm using the training data set. And I'm only fetching out two columns, 1 and 2. One of the columns I'm picking in. I am doing the pre-processing here, converting the data into the scale data. Using my train and test, right? So some of the records I'm using for train. I'm reshaping the data, and then here I'm applying the main RNN model. I'm using the sequential as regressor. LSTM I'm using long short-term memory. Units equal to 5. That means I'm using the 50 neurons. Return sequence is true. Input shape is the shape of the train dataset. Dropout 0.2. That means 20% of the neurons. Dropout concept is basically nothing but 20% of the neurons. I will not use it. Let's try to understand this also, what dropout means. So basically, when we are running the neuron, right? When we are running the network, let's say this is my input. This is my hidden layer. And let's say this is my second hidden layer. And this is my final layer, right? Let me have two more here. So this is my input. This is my hidden layer 1. This is my hidden layer 2. And this is my output. Now what dropout means? Dropout means basically when we are creating this network, right? Whenever I'll create this network, I will drop out 20% of my neurons. We have 1, 2, 3, 4, 5, 6. 6 neurons we have. So out of 6 neurons, what I want is 20% of the neurons I will not utilize, let's say in the first calculation, basically. That means roughly 6 minus 1.2, roughly 5 neurons I will use, right? Rather than using this 6, I will only use 5 neurons for training purpose in the first cycle, right? Same way here also only these 5s will be connected. These 5, this will not connect. This and this will connect it. This one will not connect. And same way here also this will connect, this will connect, this will connect, this and this will connect, and so on and so forth. In the same way here also 20% of the neuron will get connected. Let's say 3 only. So I will connect this, this, and this, 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 and this, this, and this, like that, right? So basically this dropout means out of that 50 neurons which I have used, only 80% of the neurons will be activated at a certain given point of time. So that is the dropout means. Again, I am adding the second layer of LSTM with 50 neurons. And again, I am adding one more layer of LSTM with 50 neurons. And then finally, I have the output coming in. So basically, it's a layer of 50 neurons, 50 neurons, 50, 50. So 3 layers are there. Then we have the output using the Adam as optimizer and mean squared error as my loss. I want to reduce the error, right? So loss is basically nothing but reducing the error. I'm running this for 100 epochs. That means 100 times your forward and backward propagation will happen with a batch size of 32. That means at a single point of time, 32 records will participate. Then here I am passing the testing data, doing the predictions, comparing. So in this, I am creating the chart where it is trying to compare the actual with the prediction. So here you can see that my epochs are going on. As of now, yeah, you can see everything is done. All the 100 epochs ran fine. And here you can see that the chart coming in where the real price of stock is in the red color and the predicted price of the stock is coming in the blue color. As of now, you can see, yes, there is a good amount of difference, but obviously it's a small machine and I did not do a proper regressive training of the data. That is the reason you can see that the prediction is not coming as good as, but still it's okay. right? For the basic learning of the model, it is fine. Because here you can see that there's a dip happened. Same here, dip also happened here as well. So it is doing decent, but not that great. But that is how we can train the model. Running the code will not be a challenge. Understanding the mathematics behind that is one of the important things. We discuss about the brief understanding about it, what recurrent neural network is, what is LSTM, what is GRUs. GRUs again, one of the advanced concept of LSTM, bit of a minor change. I'll show you the GRU architecture as well. All this look very complex to you. Again, we are coming from very zero background, so it is, but over the period of time, once you start exploring that, it is gonna be simple. Gated recurrent. So here you can see the architecture for gated recurrent as well, which is here. Comparison of all the three. This is my simple RNN. This is the simple RNN. Where I have only 10H function. But as I wanted to store the past information as well, I had to make the change of this. And for that, LSTM came in, which is driving the past information as well. But again, it is looking a bit complicated. A lot of calculations are happening and a lot of time consumption is also happening here. So that's why they have come up with more advanced version, which is gated recurrent unit. If you compare this and this just through visually, it is pretty much simple as compared to this. Obviously, it's in the first go, both are difficult. But if I see the network and if I'm aware of this network, then this network is very simple. So they have come up with a simpler architecture, which is going to process the data faster. The main reason is for the GRU coming in is the processing speed, right? So that's why they have come up with GRU. Now after GRU, they have come up with a lot of other concepts as well, but this is what the key point which we had, and based on that, they have invented a lot of other interesting stuffs as well, right? Let me check if I can show you one of the nice blog as well. Give me a second. Yeah, this is the blog. So this is the blog from this one of the users called Kola's blog, right? So here they have explained the entire recurrent neural network in very, not very simple way, but yes, still you can get the idea here. Let's quickly go through this so that you will understand. The benefit of neuron dropout is basically nothing, but I will just use it's something like you can say if you are aware of decision tree and random forest. So in random forest, what are we doing? In random forest, we are only picking up certain features at every point of time. We are not picking up all the features. So the same concept they tried to do in the dropout as well. Dropout is you can compare it very well with the random forest, right? Why we are doing it? The same reason is here also, just to give the variety of inputs, right? So here you can see recurrent neural network. So human don't start their thinking from scratch every second. As you read this essay, you understand each word based on your understanding of previous words. You don't throw everything away and start thinking from scratch again. Your thoughts have persistence. Traditional neural network can't do this, and it seems like a major shortcoming. For example, I imagine you want to classify what kind of event is happening at every point in a movie. It's unclear how a traditional neural network could use its reasoning about previous events in the film to inform later ones. Recurrent neural network addresses this issue. They have networks with loops in between or whatever it is, allowing information to persist, right? Here you can see the picture which I have also created. So here I have the input, recurrency is there and output is also there. In the above diagram, a chunk of neural network A looks at some input xt and output value as ht. A loop allows information to be processed from one step of the network to the next. These loops make recurrent neural networks seem kind of mysterious. However, if you think of a bit more, it turns out that they aren't all the different than a normal neural network. A recurrent neural network can be thought of a multiple copies of same network, each passing a message to a successor. Consider what happened here. Here you can see I unroll the network, right? That is what we did also. We unroll the network where we have multiple inputs coming in. So let's say I have 10 words in the input, it will open 10 times. If I have 5 words in the input, it will open 5 times, and so on. So this chain-like nature reveals that recurrent neural network are in yeah, intimately related to sequence and lists. They are the natural architecture of neural network to use for such data. And they certainly are used. In the last few years, they have been incredibly success applying RNNs to a variety of problems and so on. That's fine, right? Let's proceed. So here you can see that it's talking about the long-term dependency. Here you can see, right? So if I want to predict this word, these two words are important for me. So basically, I want to predict the farther word. And for that, the older words are important for me. So that is what it is explaining. One of the appeals of RNN in the idea that they might be able to connect previous information through present tasks, such as using previous video frames might inform the understanding of present frame. If RNN could do this, they would be extremely useful, but can they? It depends. Sometimes you only need to look at the recent information to perform the present task. For example, consider a language model trying to predict next word based on the previous ones. If we are trying to predict the last word in the clouds or in the sky, we don't need any further context. It's pretty obvious that the next word is going to be sky. In such cases where the gap between the relevant information and the place that it needs is small, RNN can learn and use the past information. But there are also the cases where we need more context. Consider trying to predict the last word in the text. I grew up in France. I speak fluent French. In between, there are some more words are there, right? So to get the understanding of this French, France is very important. So that is what I gave example of Gujarati as well. So same way, RNN is coming into picture with LSTM flavor, right? So that is your LSTM network, which is a bit of a complex one. And again, yeah, here it is explaining all the detailed steps of LSTM, how it works. Right? So that is how the idea is. Again, bit of mathematics, complex mathematics, which we are not touching upon, but I gave you the brief idea that yes, how LSTM works and what is the benefit, why they have come up with. The main idea is that why they have come up with the RNN. If ANN is there, CNN is there, what is the need of RNN? I hope it is pretty much clear that what is the need, right? So I think, yes, this is what I wanted to discuss. Any specific doubts you have, you can let me know. Any questions, any queries, please ask. I hope as a layman, you would have understand this, what it is, and you can explore now. You can explore further and you can try to understand what it is. But the main idea is that you should able to get the idea that why they have come up with this concept. Which is more accurate, LSTM or GRE? See, again, accuracy is purely depend on how much you are training and how much type of data you are having. So accuracy is not a challenge in LSTM and GRE. It's just processing time is the reason why they have came up with GRE. So how well you are training, both can give me the better accuracy. It's just how much time it is consuming is important. I can go with simple machine learning model as well, which can predict a nice outcome. It's just how well we are training. How do we manage 3, 4 words in sentence placed differently means different? For example, let's say I have a word which has multiple meaning. I think you are asking. For that, again, there is a different concepts called where we can get the context of the word, and based on that we decide. For example, the bank of the river. I have less money in the bank. So both has a different meaning. I think you are asking that. So for that, there are concept of embedding and all that takes care of the things. That maybe we will discuss if I will schedule certain session. But yes, we can do that. There are certain libraries are there. Glove, Hugging Face, all those libraries are there which can help us to take care of that. King, queen, right? So if king is there, so queen will be coming in. If king is there, so prince will be coming in. Same type of words, same meaning of words. So that type of things we are taking it quite well. Could you please share a few online resources blog on neural networks? There are certain YouTube channels available. You can search for it. There are some of the interesting videos you can find on YouTube. Right? There are various people who are discussing that. But yes, as a AI is growing in, so I would definitely encourage you guys to explore these things because now people are inclined towards AI and we have to be also very much on the lines. I would have talked about all the complex mathematics as well, but the main target audience for these session is who are fully blank on these things, and at least I can give them the idea. Maybe we can plan more detailed sessions later on, but the main motive was to help you understand. That's why we are running this series of AI, where we start with ANN, then CNN, then RNN. So just wanted to give you the brief idea that what these terms are and why they are coming in, right? So that is the main motive for me, because I want to educate those guys who are not aware of so that they can also think about these things. And I don't want to bombard with a lot of maths in the very first session to those laymen who are not aware of, because it will be very difficult. Later on, once they will find interest, we will start scheduling the session on more of a detailed concepts. Then maybe you can understand that. So the main idea is for this session is altogether to understand as a layman. All right, so no questions, I guess. Okay, I see one more. Are there any scenarios where LSTM will work better or GRU? I mean, this is all taken during designing the MN. There is no scenario as such. Again, all is mathematics, and the main reason for coming up with this networks is to improve the performance, right? So I cannot clearly say that this will work well or that will work well. It's purely based on data and how you are training the model, right? So there is no clear differentiation that this will work well in this type of scenario. I cannot say that. Next session is on encoder and decoder on 18th of this month. All right, so no questions coming in. So we'll see you in the next session. Till then, take care, guys, and have a nice day.